called linear programming. It is intense. It might be the hardest single kind of problem that you will do. Big, and they involve lots of reading, and they involve writing equations, and then graphing the equations. And then if you get them all the graphs right, then you have to find the corners, the vertices, of the feasible region that you graphed, and then you have to put them into the special optimization equation. Now each little step isn't really that hard. It really isn't. It's just that there's like 10 steps to answer a question. This is a little bit like what pre-calc is like, in that there's so many steps to answer a question. Okay, so get used to the idea of a few big hard problems instead of lots of really quick easy problems. Okay, just maybe get you used to that idea. I think you'll see it's really not that bad if you just break this big problem down into one little step at a time. All right, Keisha, or Kesha, what do you think I should say for that? Keisha. Who says Keisha? Raise your hand. Who says Kesha? Who says Kaisha? Oh, there's a lot of those. I can't believe that, but I'll go for it anyway. Okay, Kaisha is a college student who is majoring in mathematics education. She would like to earn money to help with expenses. She has 2 part-time jobs. She earns camp and 10 an hour working at a local restaurant. All right, can you see all of this could be reasonable real-world situation so far? Okay, iPad's shut. Some of you are not with me. Shut. Cute. All right. Next part is, although she would like to work more hours at the tutoring center because she wants to teach something, she likes earning the higher pay at a local restaurant. She can tutor no less than 2 and no more than 8 hours per week. In the real world, can you see how they might set rules like that? Like, if you don't tutor at all, what's the point of being a tutor? You have to tutor some hours. So they say a minimum of 2 hours a week they want you to tutor. But yet, they can set a limit on the high end, too, and say, if you work more than 8 hours, then other people aren't going to have any jobs. You know, like there's only so many people that come in for help. So they don't want you to work tons of hours. Okay, so those are constraints, it's called. Write little equations for them, like if X is going to be her tutoring time, right here, X is the hours she works at the Academic Support Center, then X would need to be no less than 2. X needs to be less than or equal to 2. See where I'm going with this? And X also has to be, what's the other one? Greater than or equal to 8. All right. Now let's talk about the other place. Have we set any limits on the restaurant? Has there been anything so far that's a limit on the restaurant? Not yet. Okay, so now, what's Kesha's maximum earning potential as she works at a total of no more than 20 hours per week? Ooh, that sounds like an equation to me, too. Raise your hand. Yes. Oh, are the signs reversed? Sorry about that. Say this again. X needs to be at least 2, so I had the wrong sign in there. Okay, and X needs to be less than or equal to 8. Is that correct? Okay, good. So, now back to what I was talking about. What is her maximum earning potential, as in the most she can make, if she works a total of no more than 20 hours per week? That is another equation. All right, so now we're going to break this into chunks here. And part A we've already done. We've got 2 constraints on the tutoring. That has to be less than or equal to 2, and X has to be less than or equal to 8. Why don't you catch up with me now on your iPads? Write those 2 equations in. I'm proud of you for having a printout. That was smart. Keep it up. Excuse me. Okay, and then part B, number of hours she can work at the local restaurant. We didn't set any limit, but in the real world, think for a second. What's the smallest number of hours she can work there? Nope. Nope. Technically, you could have any number of hours that's really, really small, except what's the smallest of them all? 0. Do you get how the number of hours she has to be, this is why, has to be what? Not X, this is X. There you go. Y was the restaurant. Greater than, could it be equal to 0? Yes, because they didn't say anything about limits. Now I know, real world, they probably want you to work, but it doesn't say anything in the problem. So I should say it could be 0. Y has to be greater than or equal to 0. Now again, I know in the real world you might even argue that x, y would have to be greater than 0, otherwise you don't really have a job there. But I guess, in a 1 week, is it possible your employer might say you don't have to come in this week? So 0 is possible. But -1 is never going to happen. That'd be awesome if you worked at a place that gave you time. You work there, and then you have more hours in your life. All right. The only way, I've thought about this, the only way that you could get a longer life than anybody else, less. What if I had a science teacher when I was in 7th grade? He swore that he got by on 4 hours of sleep every night because he did some kind of meditation or something during the daytime that helped him not need as much sleep. So he could get by on 4 hours sleep every night. So he had 4 hours extra time for whatever he needed to do for his whole life. That's actually pretty cool. Now, but there are also downsides to being sleep deprived. If you aren't somehow getting the rest you need, like he was saying he was getting it through meditation, if you aren't getting the rest that you need, crazy. You're like there is psychosis that can happen from not having enough sleep. Yes. It is possible. He would disagree with you right now if he was here, but he's probably dead now, so I don't think he'll disagree anymore. Well, I'm 45, so he was out, and I had him when I was like 11. So okay, I don't know. He was like 45 or something. That's all right, Mister. You're awesome, and I hope you're still alive. So anyway, going on to part C. Total number of hours she can work during 1 week. In 1 week, the total hours she can work is the x plus the y. Get that? Wait, we'll talk. X plus y has to be what, though? Nope, not exactly 20. What did we say? No more than, another way to say that, less than or equal to 20. There you go. All right, now, the graphing. We're going to just make a sketch of this one. You have a question? I get what you're saying, and I would even agree with that, but that's going to be handled by this one. See this equation right here? I don't know why I don't know what happened there. Anyway, that's going to be handled by this equation that has the less than or equal to 20 on it, so don't worry. When we say common sense constraint, we're usually talking about don't let y be 0 or x be 0. Right. This graph is going to be kind of weird because normally we have time on the bottom and most of our graphs, but here, okay, don't do that. Stay with me. X is the number of hours she works at the Academic Support Center, so that's the tutoring. So I want you to put underneath the X, put tutor. And Y is the restaurant. So if we put a dot right here, that would mean she worked like 5 hours of tutoring and 5 hours at the restaurant. Get what I mean? All right, so now, how do we graph these? X is less than or equal to 2. So we find where X is 2. Draw a line like this. Yeah, I might have just said that wrong. X is greater than or equal to 2. So I go to the line. Notice I don't shade in the whole thing. It gets where other that you need to shade. Next, X has to be less than or equal to 8. Here's 8. And less than 8. Next thing, I have to be greater than or equal to 0. That's a line across the bottom here, which is saying that we have to stay above 0. thing plus y has to be less than 20. There's one of your more challenging ones. How are you going to graph that? Yes, XY chart, that would work. Or you could solve it for y. And you'd subtract x from both sides. You'd have y is less than or equal to 20 minus x. And a lot of people have a misunderstanding. They're like, oh, there's a negative there, so you got to switch the sign. And if you multiplied the equation or the equation by a negative, I didn't. I subtracted something. You can do that without switching the sign. Okay, so now, if I was going to graph this, I'd probably put the 20 on the other side and say negative x plus 20. It's the same exact thing. I just see it better now. That's the y-intercept, and that's the slope. It's negative 1. So here's 20, let's say. And let's say it's going down like this for my slope. And I want to be less than that, so it's going to be like this. Can you see where all those lines overlap? They all overlap in here. It means the point is possible for her. She could work any of those options that I just shaded in there. Now, which of them is likely to make her the most? This one will make her the least money. Yeah, that. Now, why? 'Cause she's only working like 2 hours of tutoring, and that's it. It's 2 comma 0. Or, wait a minute. Yeah, 2 comma 0. Probably this one, right? Is it possible this one could be it? Yep. Could be one of those two. How do we know for sure? Well, we plug it into what's called the optimization equation. The optimization equation is, or it's otherwise known as the objective function in some contexts, is where you figure in the one thing we haven't done yet, which is money. Do you notice we don't have anything about money on this whole screen? In the problem, they talk about $8 and $10, but there's nothing on our graph about money. It's all about hours. So, how do I get the money into it? Here's how. At the top of your paper, or at the top, no, your virtual paper, I want you to write this equation with me. I got x times 8 plus, and then somebody can figure out the rest of this. Yeah, I was afraid of that. Okay. Yeah, it's not a good. Okay. Stay with me. You're going to lose those things. Okay, so now we got to make this objective function, and so far we've put x plus 8 on top. That's the money. $8 an hour for the tutoring. So the rest of the money. Do the rest of it? Yes. And that is total amount of money you're going to make, because this is how much tutoring you're going to do. This is how much restaurant you're going to do. And it makes a total, and we're going to call it P for profit. It's not really profit, but it's going to work well on your next problem that you do for your homework. All right. And now, if we were to pick, I'm not sure exactly because my graph is not awesome here, but that point, let's say, I think it's on the line where x was 8. So let's say it's 8 comma 10 or something. Let's say that point's 8 comma 10. That means I have x is 8, y is 10, and she'd make 8 times 8 is 64, plus 10 times 10 is 100, $164 profit. You see how that point gives me $164 of profit? Okay. Then this other point here is higher. It's over 2 and up maybe 18. I think it might be 2 comma 18. So then that means x is 2. So I put in a 2 for this one. And 2 times 8 makes $16 for this. And then 18 times 10. 18 times 10 makes 180 for that. So 180 plus the 16 makes 196. This one, we use the objective function to plug in our corners, and we figured out that you either make 196 or what was it? 64. Obviously 196 is better. It's a fair amount of work, but 96 or 164 are the two options, and 196 is better. So bottom line is that the 2 comma 18 was the one that optimized for earnings. That is serious math. That's like the college level figuring out business problems that can actually work in the real world. A company could give you their constraints, and you could figure out, okay, the maximum number of units of CDs versus VCRs. Now VCRs are pretty much gone. CDs, they're pretty much gone too. MP3 players versus, I don't know, Bluetooth that you should make would be what? And you could say you should make 2 Bluetooths and 18 MP3 players. Anyway, this is good real world stuff, so I'm trying to say. All right, now, your homework. Let's get started. I'm going to give you only 2 problems for homework. I answer those by talking you through them. Now we're on to the homework part. All right. For each situation, find the optimal situation by doing these steps. Basically, you just need to do each of these little things. I know there's a lot of steps, right? So we wrote them out for you. Here are your A, B, C, D, E, 5 steps to answering these questions. Okay? Eli's lunch cart. That's going to be your first one. Now, I know you can graph on the iPad, but I also feel like it's one of its weaknesses. So I have got a piece of virtual, actual, not virtual, paper that's got a graph on both sides. Use pencil because you only get 2 when you have 2 problems. Okay? So there's a front and the back side is all you got. So anyway, you're going to be making a nice graph for me on paper. And you answer questions that involve the equations and what on your iPad. But then I do want a virtual, I want every now and then, just rarely, but I want you to actually do something on paper for me. So, no, the notes problems were just for practice. And I did talk you through all of that stuff. So okay, whoever does get a double-sided one, I'll have to give you 2. Who did not get a double-sided? Weird. That's all right. I got plenty of these. I have another 100 sitting in my office. So if you did not get a double-sided, I'm throwing extras in the front of each row here. How about you got it double-sided? Okay, that's weird. There was one little set of singles. Okay, enough of that. On to Eli's lunch cart. He sells burritos and chili. To stay in business, he must sell at least 30 burritos and 10 orders of chili each day. That's an equation. Right away, equation. And one of the first things you got to do is pick what X and Y are, and they've already told us. X is going to be burritos, Y is going to be chili. All right, so if we have to do 30 burritos, that's X has to be at least 30. How do I do that? Greater than or equal to 30. Okay. And 10 orders of chili each day. Then Y has to be what? Greater than or equal to 10. Okay, because of limited space, go over 40 on the chili. Y is less than or equal to 40. Or 70 burritos. X less than or equal to 70 can be made. The total cannot exceed 90. How do you do that? X plus Y. What? Yes. Excellent. And then the profit, we're going to use that to write the little profit equation. Remember that one? P equals? Our profit will be $1.5 per burrito. And the burritos were the X. And then how do I finish? Yep, 165. All right, you've got everything you need. Now you need to graph it on that piece of paper. And remember X, which is the bottom part on the graph, you're going to as burritos. And Y is CHILLI. Is there supposed to be 2 L's in chili? Maybe not. Fine. Chili. Burritos versus... Do a nice graph. I'd make each box be 5. That's probably going to make it spread out the nicest on your graph. I had some kids doing 2.5, and that was okay. I had some kids trying to do each box was 10, but it ends up being a pretty small graph. Okay, So graph them. You'll see where it all crosses. See where everything crosses? You'll have a feasible region. Let's say it looks kind of like that. Then you'll take the corners of it and you'll plug them in to the objective function, which is this guy. You'll plug them in here and here, and you'll figure out how much profit you make at either spot. Another problem like this, the next one about Yakima's bike shop. And try those two. Those are your homework for this weekend. Answers are posted. I know. Do the first two. Because I feel like here started together, the lunch cart one, and then the one about the... It's your only homework.